Is there really a pot of gold at the end of the rainbow? Is there a child who dares to dream beyond mystery? Colors have significance, science and poetry. Perhaps this combination fascinated the mind of a little boy who lived by the seashore, listening to the sound of his father's violin, looking at the distant seas, and trying to fathom the infinity of shades within a single color. This was the quest of Chandrasekharan Venkataraman. The small village of Thiruvannaikaval lies along the banks of the river Kaveri in Tamil Nadu. Here, on the 7th of November 1888, was born to C. Venkataraman and Parvati Ammal a second son, Chandrasekharan Venkataraman. Not realizing then the enormous inroads in science that this extraordinary child would make, Venkataraman was a school teacher and a scholar of physics and mathematics. The Raman home had an atmosphere of music, Sanskrit literature and science, and these were an integral part of Dr. C.V. Raman's formative years. When Raman was 4 years old, his father moved to Visakhapatnam to take up a lecturer's job in Avian College. Unlike his father, young Raman was not strong, but what he lacked in physical strength, he made up intellectually. He excelled in studies. Raman developed an interest in physics while still at school. Incredibly, Raman was just 11 years old when he passed the matriculation examinations, standing first. He next joined the Avian College to study for the intermediate. In 1903, he went to Madras with a scholarship to study for a BA degree in the Presidency College, the premier college in the South. Besides a flair for physics, he also developed a great liking for English. Raman passed the BA examination in 1904, obtaining the first rank in the university and winning gold medals in physics and English. His teacher suggested that he should go to England for further studies, but the civil surgeon of Madras ruled this out. Unable to proceed to England for higher studies, Raman enrolled in the MA class in the Presidency College to study physics. Raman made good use of his spare time by tinkering around the laboratory. He discovered the essence of research, and it was this spirit of inquiry that drove him to do experiments throughout his life. During the British Raj, it was not easy to continue in research. As a full-time career, government service was the only option left. But he could not go abroad to do his Indian civil service due to ill health. In 1907, he cleared the examination for the financial civil service. One day, he heard the strains of the veena emanating from his friend Shivan's house. The player was Lokasundari, Shivan's sister-in-law from Madurai. Soon after, he married Lokasundari. In 1907, at the age of 18, Raman was posted as Assistant Accountant General in Calcutta on a salary of 400 rupees. Instead of entering science, he entered government service. He used to travel to office by tram every morning. One morning, the tram that took him to office stopped near 210 Beaubazar Street. He saw the signboard, Indian Association for Cultivation of Science. His curiosity was aroused. While returning from office the same day, he alighted from the tram and peeped through the window and saw the instruments of a laboratory. He knocked, and Ashutosh Dey opened the door and introduced him to the Honorary Secretary Amritalal Sarkar, who was the nephew of Mohinderlal Sarkar, the founder of the association. Raman was welcomed to work there.
He wanted ISCS to really get involved in fundamental research at a time when India was colonized and there was no British support for fundamental research. This was a great event in the annals of Indian history and is a great heritage of the Indian freedom movement.
The din and bustle of the trams, the hand-drawn rickshaws, and his alienation as a man from the south did not deter him in his quest. 210 Beaubazar Street soon became the center for Raman's original scientific research. His days were long. He attended office from 10 in the morning till 5 in the evening, and after that worked in the laboratory till 10 at night. Every sunset that Raman saw at the association office was a renewed promise of a new dawn in the study of science. He made many contributions in many areas, such as acoustics, optics, diffraction, and scattering. In between, he was transferred to Rangoon in 1909 and to Nagpur in 1910 for brief periods. But Raman was soon back in Calcutta. He moved into a house adjoining the association and had a door put between his house and the association so that he could walk into the laboratory at any time. Research was resumed with renewed vigor. Luminaries of that period, such as the scientists Meghnad Saha and K.S. Krishnan, were his associates in scientific research. Raman's forte was experimenting with waves, both of sound and of light. Here he attained heights comparable to those attained by masters like Helmholtz and Rayleigh. On occasion, he even outdid Lord Rayleigh, who later recognized Raman's work in this field. Then came the turning point in Raman's life. Sir Ashutosh Mukherjee, Vice-Chancellor of Calcutta University, had established a college to popularize science. Several chairs in the names of donors were set up. C.V. Raman was offered the Taraknath Palit chair. Raman, the scientist, gave up his job in the finance department and accepted the offer. In doing so, he reached the first milestone of the path that would ultimately lead him beyond the rainbow. Raman went to Europe in 1921 as a delegate to the Universities Congress held in Oxford. During this voyage, he came face to face with the grandeur of the Mediterranean Sea, its beauty, its moods, and in particular, its blueness. The more he saw of it, the more he wondered. The much admired dark blue of the deep sea is simply the blue of the sky seen by reflection, was Lord Raleigh's statement, soon to be refuted by Raman. He observed that even when huge waves rolled over the surface, the blue tinge remained. It flashed across the mind of this genius that the blue color might be caused by the scattering of the sun's light by water molecules. His research paper was sent to the Royal Society of Science, and thus was established the theory of molecular scattering of light. On his return to Calcutta, Raman continued his quest. Centuries earlier, Sir Isaac Newton had used a prism to disperse light into a spectrum of colors. When a beam of sunlight is passed through a glass prism, a spectrum of color bands is seen. A beam of light that causes a single spectral line is monochromatic. But when a beam of monochromatic light passes through a transparent substance, the beam is scattered. We see a rainbow in shades of red, orange, yellow, green, blue, indigo, and violet. The white ray of the sun includes all these colors. It was clear to Raman now that the beam of incident light was monochromatic, but the scattered light due to it was not.
The Raman effect is actually change in the color of light when light is scattered from a material. For instance, you may have a light which is blue coming in, but light that goes out may be, say, red, for instance. This change of color, of course, technically is change in wavelength, and therefore we say Raman effect is a change in the wavelength of light when it is scattered from a material.
In 1924, he was elected a Fellow of the Royal Society of Science. In 1926, Raman started the Indian Journal of Physics. His research on sound became famous the world over. On February 28, 1928, at the IACS laboratory in Calcutta, Raman discovered two low-intensity spectral lines that confirmed his theory. To celebrate this discovery and to salute the genius of her son, C.V. Raman, India observes the 28th of February as National Science Day.
Sir C.V. Raman was not only a very great scientist, he was an extraordinary person, extremely strong, with great oratorial skills, and his interest on all things in and around him was so great, and his capability to essentially sort of explain them was so lucid that he immediately made a mark anywhere he went.
On the 16th of March 1928, C.V. Raman announced the new phenomenon discovered by him to the world. This was aptly termed the Raman effect. It took a Raman to focus on what happens when one such light beam of monochromatic or one-color light passes through a transparent substance. Naturally, the beam scatters in random directions, but one tiny part of the scattered light changes its frequency from that of the initial color. The spectral lines in the scattered light were known as Raman lines. He was the forefather of laser, which came into use in the 1960s. The Raman effect is an effective tool for studying the molecular structure of chemicals. It has vast applications in other branches of scientific research as well. Medicine, biology, physics, astronomy, and telecommunications. In 1930, history took note of this great scientist, and he became the first Asian to be honored with the Nobel Prize in Physics. At the ceremony, Raman used alcohol to demonstrate the Raman effect. Later, in reply to the proposed toast, he drank water and said with his characteristic wit and humor, "Sir, I know what the Raman effect is on alcohol, but I do not want to try the effect of alcohol on Raman." Raman's second decade at Calcutta continued, as with his students, he studied a variety of problems, like the elastic and optical properties of crystals, the physics of celluloids, and X-ray diffraction. In 1932, the doyen among industrialists, J.R.D. Tata, invited C.V. Raman to join the prestigious Indian Science Institute. The diffraction of light by ultrasonic waves in a liquid was explained by Raman and Nagendranath. This theory is called the Raman-Nath theory. Scientific research in India was Raman's dream, and so he established the Indian Academy of Sciences in 1934, where he was lifelong honorary president. Raman started the journal Current Science. To date, the Indian Academy continues to publish the journal every month, along with numerous other magazines. Success often breeds envy, and Raman's success was no exception. He was criticized, and he promptly resigned from his post at the Indian Institute of Science. He decided to give form to his dream and start his own institute for pure fundamental research. The king of Mysore granted 24 acres of land and the finance to Raman to enable him to establish a research institute at Hebbar, Bangalore, which is now known as the Raman Research Institute. The institute was formally inaugurated in 1948, and Raman became director for life. The institute had a large garden with tall eucalyptus trees. Humorously, he said, "A Hindu is required to go to the forest in old age, but instead of going to the forest, I made the forest come to me." It was under these auspices that he continued his research on sound, light, rocks, gems, birds, insects, butterflies, seashells, flowers, the atmosphere, the weather, and the physiology of vision and hearing. He broke the watertight compartments of scientific research. His study covered different fields of science, such as physics, geology, biology, and physiology. "Research is strange work," said Raman. "Success in it brings limitless joy, whereas failure pushes one to deep despair. But one must not give up." The Raman effect was the beginning of a journey, not the end. Today, at the Raman Institute of Research, the approach is different, but the base is the same. The impact of modern science can be seen, but we cannot forget the foundation stone laid by this genius of science. The Raman Research Center is today buzzing with activity in the field of space research, especially its radio telescope department. Today, the Raman effect, which had its origin in equipment not costing more than 300 rupees, is used in the most sophisticated instruments of scientific research. The Raman spectrograph has developed in different stages. The effect of light is seen in all its perspective and in the minutest detail.
The Raman effect was one of the greatest discoveries of the 20th century. In fact, over the decades, the techniques of experimentation have changed. Like Professor Raman used sunlight for some of his experiments, whereas we now use laser beams for the sources of the experiment. Similarly, the detector part also has changed. Like he was using a prism spectrograph, whereas nowadays people use CCD cameras. However, it's very important to notice that the basic principles have not changed. They are the same all the time.
To this day, the Indian Association for Cultivation of Science at Calcutta works with enormous vigor. Raman's indomitable spirit has urged present-day scientists at the Institute to try and find a cure for cancer. Solar energy research today has opened new avenues at the Indian Association for Cultivation of Science.
Cultivation of Science is very proud of him, because how from the very beginning, he had such a small money, but by his very genius and commitment, he showed how research can be done. So he continues to be a great source of inspiration to all research workers in this institute, and not only in this institute, I think for whole of India.
The relevance of the Raman effect can be seen today in the fields of space technology, telecommunications, and information technology.
It had been completely unexpected that this effect should play any role in an astronomical object. In fact, about 10 years ago, the first scientists discovered these very weak Raman features, and I believe that they may hold the key to identifying some unknown, heretofore unknown spectral features in gas clouds. And so, in fact, one of the things that I am doing here is increasing my understanding of the Raman effect so I can go back to the United States and understand its application to astronomical objects.
Panchavati, the beautiful house where Raman lived, today houses many of his personal relics, the letters of appreciation that he received from the world over, and his musical instruments are preserved here and bear witness to this man who was an aesthete and an artist. The Raman Library houses his own collection of priceless books. All the articles which were the product of his research and expertise are preserved here for time immemorial, for the enrichment of mankind. The archives of the Raman Research Institute contain his lifelong collection of pearls and many types of precious and semi-precious stones. Raman, the scientist, had both poetic insight and a scientific temperament. Color and light always delighted him. He collected rocks and precious stones and could create small twinkling worlds by switching on small ultraviolet lights. He loved flowers for their colors. He studied the amazing sound qualities of Indian instruments like the mridangam, the tabla, the tanpura, and the veena. Sprinkling fine grains of sand on them, he watched the sound patterns as he tapped on the instruments. The intuitive understanding of our forefathers regarding the nature of sound and acoustics stunned Raman.
He was fond of music, and not only fond, he could analyze music. In the sense, you know, like these great experts of to him, it was mostly South Indian classical music, Carnatic music. Because after all, he was a South Indian. And then colors, he would just dream and feel so happy looking at different colors.
Raman was a true karma yogi. Following in his footsteps, his nephew, Subramaniam Chandrasekhar, became a world-class astrophysicist and won the Nobel Prize in 1982.
We should try to do something original, just as what Raman and others like Bose and Saha did. That spirit we should not give up. Not copying foreign science, but learning from foreign science, oh sure, that is necessary, but we should also try to teach them something.
Science was Raman's God, and work was his religion. He believed that new discoveries confirmed the existence of God. At 82, he was actively inviting young scientists to present papers.
I had a very happy meeting with Sir C.V. Raman, and this was way back in 1950. I stood up, did him a namaste, and said, "Sir C.V. Raman, I presume?" He said, "Yes, yes. Well, who are you?" I said, "Sir, I'm the Free Press Journal correspondent here." So I said, "Sir, may I ask you a question?" He said, "What is it about?" I told him, "Sir, I had read your speech in Akashvani, but this is one thing I didn't understand." That was all. For the next 1 hour, believe it or not, he began to explain to me what it was all about. And at one point he was so excited, he literally dragged me to the compound, picked up a handful of gravel, and began to tell me the structure of diamond, of all things. It was the most exciting encounter I have had with any Nobel Prize winner.
A few days before his 83rd birthday, Raman suffered a mild heart attack. He recovered quickly, but passed beyond the barriers of light and sound on the 21st of November, 1970. Today, Dr. C.V. Raman stands tall, bridging the rich heritage of the past with the vibrant present and the infinite possibilities of the future of a rapidly changing global scenario. Like nature, he can be described. He cannot be defined.